Now that we've got location data for the device, we can start to request the weather information from OpenWeatherMap. But before we write the Java code, let's talk a little bit about networking to provide some context for what we're about to do. Say we type in www.google.com into the address bar of our Chrome or Firefox browsers. What happens? The browser sends a request to Google servers and we get back some files. In the case of simple websites, these are HTML and CSS files. Our browser then opens and interprets those files and we see a web page being displayed. In other words, putting in the URL and pressing enter is sending instructions to a web server, directing that server to fetch us the requested web page. That URL that we have provided is an address in the data server. It tells the server the location of the files that we want to access. When the internet was invented, it quickly became apparent that computers should follow some sort of common rules to communicate. So the way that browsers talk to servers has been standardized. In other words, there's a set format or protocol for making requests and receiving responses between computers. This standard format is known as HTTP, or Hypertext Transfer Protocol. HTTP was invented by our old friend Tim Berners-Lee and his buddies at CERN. Now there's actually several kinds of requests that we could make to a server using HTTP. One type of request is a GET request. With a GET request, we ask the server to send us a specific file. Another type of request might be a POST request, for example. With a POST request, we're asking to add data to the server. And yet another type of request would be something like a delete request, where the client is asking the server to delete some data. There are actually quite a few different types of requests that one could make to a web server, but in our Klima app, we're only going to be making GET requests to retrieve the weather data. Okay, so far we've talked about how a client, like our computer's browser, sends a URL to a website's server. This is the part where we're making a request. Suppose we're sending a GET request, and if everything goes well, then the server responds with some files. Since the communication between the clients and servers all follow a certain standard, namely HTTP, the kinds of responses that we can get from a server have also been codified. In other words, every type of response from a server has been assigned a status code in the form of a number. Have you ever typed in the wrong URL or tried to access a part of a website that just didn't exist? If so, you're already familiar with one of these status codes, the 404. These days, it seems that every company uses their 404 page as an opportunity to be hipster and get creative on their website. For example, check out the 404 page of GitHub when you put in a URL that doesn't lead anywhere. Dropbox actually has a pretty funky 404 page too. Now, other status codes besides 404 have different numbers associated with them. If all goes well with a request over HTTP, the server will send the status code 200. Okay. However, we can get a whole bunch of different status codes if things don't go well. For example, if we try to access a page that requires us to, say, log in first and we don't have permission to make the request, we might see something like a 401, unauthorized status code. On the other hand, if something goes completely wrong on the server side, then we might see a status code like 502, bad gateway. If you'd like to check out the whole gamut of different status codes, I recommend taking a look at this handy list on Wikipedia. The main thing to take away from this discussion about responses from servers is that every response comes with a status code, and when something goes wrong with our requests to OpenWeatherMap, we can get a better insight into any of these problems by looking at the status code that accompanies the error message. To obtain our weather data, all we have to do is send a request, and the way of sending that request to OpenWeatherMap works very, very similar to how we navigate to a website in the browser. With OpenWeatherMap, we won't be typing a URL into a browser, but we'll also send their server a similar request for data. OpenWeatherMap provides an API, or Application Programming Interface, that allows us to communicate with their servers and obtain weather data to display in our app. So what exactly do we mean by API? An API is essentially a contract. This contract lays out the rules that our program must follow in order to obtain data from the server. To use an analogy to look at an API in a different light, Imagine that we wanted to contract a builder to build us a house. Our contract with the builder would have to specify what it is that we would need to provide in order for the builder to deliver us that house. We'd have to provide the builder with inputs, like information on how many rooms we'd like, but maybe also other kinds of inputs, like bricks or tools or money. These inputs form our parameters of the API call. In our case, we want to use OpenWeatherMap's API, so we will have to follow the rules that OpenWeatherMap lays out in their contract. The parameters or inputs that we need to supply OpenWeatherMap is information that it can use to figure out our location. That way, OpenWeatherMap servers can respond with the weather information associated with the device. The rules of an API are always specified in the documentation page of the people who made the API. Let's take a closer look at OpenWeatherMap's API documentation to see an example of how they have chosen to present this information to us. Here we can see the URL that we need to supply to make a particular API call. OpenWeatherMap have also outlined the names of the parameters that we need to supply. And finally, they have given us an example along with what the response from the servers would look like. Now, the example response here might look a little bit intimidating at first glance, but we'll discuss the structure of the data in this response in more detail in a subsequent video. Okay, so now we've decided that we won't be typing a URL into our browser, and we've looked at the API documentation. Let's deconstruct exactly what we would need to supply OpenWeatherMap server. How does our request actually need to look like? In the Klima app, we will be making two kinds of requests. Both of these will be the GET requests that we talked about. Here's an example of our first request for weather data. All of OpenWeatherMap's API calls start out with the same URL, api.openweathermap.org/data/2.5/weather. After this piece of text, the API expects to find the parameters of the API call. As part of this request for the weather data, we're supplying the latitude, the longitude, and the app ID. Lat, lon, and app ID are the parameter names. The values for these parameters are 37, -122, and a long string of characters that represents the app ID. In the past, OpenWeatherMap did not require an app or an account ID to request weather data from their servers, but these days one has to sign up for a free account in order to get this app ID. Now let's take a look at the second type of API call that we're going to be making. The request for the weather data in a particular city looks like this. The pattern stays exactly the same. We start out with the base URL, and then we append the parameters. In this case, the names of the parameters are Q and app ID. The value of Q is the name of the city for which we are requesting the weather. Regardless of the kind of data you're going to be looking to fetch in the future, the central idea behind APIs is always the same. Your program has to make a request in line with the rules of the API. You'll be supplying parameters to the server, and the server will respond to your request with data. The key really is being able to make sense of the documentation. But being able to tap into APIs will open up a whole new set of possibilities for your future apps. For example, here's the API to retrieve London transport travel information. In fact, you can access all sorts of information through the Transport for London API, including information on air quality, bus arrival times, and accident stats. But if you're more of a finance guy, you can get access to APIs where you can query for stock prices. And finally, the big tech companies in Silicon Valley also provide APIs that you can tap into, and that includes the likes of Facebook, Instagram, and Twitter. Point being, once you figure out APIs, the world is your oyster.